Okay, we are looking at IP sequences, and this was one of the problems that you had. You had a sequence, right? And we're supposed to write the function. So we want to figure out what the function is. Write the rule, write the function. So we have only talked about arithmetic and geometric sequences, and that has to do with their growth. They either grow by adding the same number every time, and we can check and see if that happens here. We can do 125 minus 25. That's 100, so I added 100 right here. If I do 625 and I subtract off the previous number 125, I get a different number. I added 500. So it was 100 to add here, 500 to add there, quite a bit more to add there. It's not adding the same number every time. So we need to find out if we're multiplying by the same number. What we're looking for is a common ratio, and we can sort of figure out what that multiplication problem is by doing it backwards and getting the division. Instead of asking myself 25 times what is 125, I'll do 125 divided by 25, figure out how many times it fits in there, 5 times, and then we'll see if that's my multiplier. 625 divided by the previous number 125, right? Oops, I think I hit times. 625 divided by the previous number 125 is also 5, right? So now I can kind of test it with just multiplying by 5, right? Is 625 times 5, is that going to give me the next number, 3,125? It is. All right, so we have a geometric sequence. It's growing with addition. Or sorry, growing with multiplication. Geometric. And that means it is exponential. It's growing with multiplication. So that multiplier, I'm actually going to call it the common ratio. That's the term that we use in sequences, because we set up a fraction, we set up a ratio, this number over that number, this number over that number, this number over that number. Common ratio, but it is the multiplier. And in this case, it is 5, right? 125 over 25 equals 5. So because it's exponential, I know it's going to take this structure, f of x equals a times b to the x. Now I've already determined that my common ratio, my multiplier, is 5. So the b value here is going to be 5. What I need to figure out is what is my 0th term? What's my starting value? If I input 0 here into this function, this goes away. It's going to leave me with this, which means I need to kind of back my pattern up. Right now, this is my first term. It's the first term of the sequence. It's the second, third, fourth. I need to go backwards and get the 0th term. Now, it's not technically part of the sequence, but I need it for the pattern. So instead of multiplying by 5, I'm going to take 25, and I'm going to divide it by 5. So my starting value is, also 5. That's kind of boring. It's the same number. So I divide by 5. I'm going to end up with 5, which means my starting value, or my 0th term, also my starting value, or my initial value, right? Okay, that is also 5. All right, so this term right here, and it's going to be my starting value there. So now that I know both pieces, it's going to look like this. Now, you may be tempted to make that 25 to the x. Do not do that. That is not correct. We need to keep these separated with multiplication. That's an exponent there that you would technically have to do first before you can multiply. So it's 5 times 5 to the x. Now I can sort of verify that this works. Look, my 1, 2, 3, my 4th term is 3,125, meaning if I input 4, if I do f of 4, 5.5 to, it's not 5.5, 5 times 5 to the 4th, that's going to give me hopefully 3,125. 5 times 5, raise that to the 4th, 3,125. So that would be my answer then. And I can show you real quick that that if I do make this 25, like if I input 25, if I did that first and I raise that to the 4th power, look, that's going to be a wildly different number. The 4th term is not 390,625. That's my final answer. That's it as a function. That's getting my growth. My first term 25, common ratio 5, starting value also 5. That's the function. Message me anytime with questions.